Alright, so I'll talk about the partial fraction the first page, but the derivative second page, if you have y equals natural log of x squared sine x over, I don't know, natural log of x. So if you're trying to find the derivative of that, it'd be better to just use our log properties first before you do the derivative. So just rewrite it using natural log of x squared plus the natural log of sine x minus the natural log of x. Okay, so do those log properties look familiar? Yeah, okay. And if we want, like if you're taking a log, if it's log or natural log of anything multiplying, you can just separate them with a plus. We could also move that 2 out front. So it gets to the point where now it's quite a bit easier to find the derivative just because we used our log properties. So then we could do y prime equals 2 over x plus 1 over sine x times the cosine x, which is actually, this is cotangent x, minus 1 over natural log of x times the derivative inside, which is 1 over x. And then that's about, you could clean it up a little bit, but that'd be your answer. Just using logs. I've also seen it, and I don't have any examples, but if you had just the y equals x squared sine x over natural log x, if that was the original right here and it wasn't natural log, it was just x squared sine x over ln x. This one has a natural log, this one doesn't. You could actually do the natural log of each side. And then you can use your log properties. And then when you do the derivative, it's, natural log y on the left, it'll be 1 over y prime equals that. So there's just one more step. If you wanted to, that's an option of when you're doing derivatives. Questions on that? The bulk of today is going to be on partial fractions. Carter, no questions? You don't like it?
No.
This? That's derivatives. That's first semester stuff. Calc 1. We're moving into Calc 2 stuff. Integrals. Oh, I wouldn't call it Calc 2, I guess, but second half of Calc. Okay. So if we're given, this is integrals, oops, that's not how I spell integrals, with partial fractions. That's the abbreviated title. So we're going to use partial fraction decomposition to evaluate integrals is what we're actually going to do. So if I have integral of 2x plus 3 over x squared minus 3x minus 10 dx. Well, that was almost a u substitution. I'll make it 2x plus 8. Okay. So if you're given this integral, you could do a u substitution where you choose your u to be the bottom, but your derivative is going to be 2x minus 3. And it's not going to completely cross off the 2x plus 8 on top. And this could be 3x plus 8, it could be 4x plus 8. So it's actually, if you think about it, kind of unlikely that a u substitution would work here because the derivative has to cross off the numerator, which we'll learn different techniques in order to do that in Calc BC for those that are going to be there, but this is partial fractions or partial fraction decomposition. So what we're going to do is we're going to rewrite 2x plus 8 over x squared minus 3x in a different way, in a way that we can evaluate the integral. We can find the antiderivative. All right, so what we do is we're going to factor the bottom. So it's 2x plus 8 over x minus 5x plus 2. And they're always factorable on the bottom. If it's not factorable, this is not what you should do. So if it's factorable, it might be what you should do. And in this chapter, it probably will be what you do, but it's not always the case. Okay, so I factor it. Now I'm going to say A is over one of the factors. And then I'm going to say B is over another one of the factors. So I'm going to figure out what A and B are, and that's our rewrite is going to be in this form. We just have to figure out what capital A and capital B are. So step 1, factor the bottom. Step 2, put A over one of the factors, B over the other factors. So now we're going to have to multiply both sides by whatever this bottom is. X minus 5 times x plus 2. We're going to multiply that to both sides of the equation. Always multiply by the bottom here. So on the left, you can see this will cross off with this, so it's just going to be 2x plus 8. These x minus 5s are going to cross off because it's going to be a times all of that stuff on top. You could think of it as over 1. So this is going to be on top of the a, so the x minus 5s are going to cross off. So we have a times x plus 2. And then these x plus 2s are going to cross off. It'll be b times x minus 5. So far, so good. Factor the bottom, put a over one of them, b over the other, and then multiply both sides by whatever this is right there. Okay, so I'm going to get rid of the parentheses. So now we're going to set up a kind of a system of equations where this problem here has just linear terms and constant terms. So I have x terms and number terms, but there's no x squareds, no x cubes. So I need to assign one equation for the x terms and then one equation for the numbers of the constants. If there was an x squared or there are x squareds in here, you'd have to have a third equation. But for the x ones, I have two x's on the left, and I have a plus b x's on the right. So I have two x's there, I have a plus b x's. So that's just the number of x's on each side. And then the constant, or the numbers on the left I have 8. On the right I have 2a minus 5b. And I have a system of equations. Okay, so we could use elimination, we could use substitution, you could use your calculator and a matrix. That'd be the easiest if you can remember how to do that. Should I teach you? Yeah. Okay, so it should be set up so that these constants are over to the right, so I'm going to rewrite that as a plus b equals 2. Because we don't want to have to remember how to do algebra, right? At this point, we're arrogant calc students and we're above algebra, so we'll just use a calculator. Okay, so we're going to have to set up a matrix. Our coefficients will be 1, 1, 2, and on the bottom I have 2, -5, 8. Now it would literally, it would be faster to not do this. But you might end up with 3 equations and 3 unknowns, and then I would definitely use a matrix. So I'm just going to show you how to do it with a matrix. So on a calculator, we're going to go to matrix, if you can believe that. It's right there. And we're going to edit. And this is a 2 by 3 matrix that we're dealing with. If it was a 3 equation, it'd be 3 by 4, but here it's a 2 by 3. And I'm just going to edit matrix A that's already in my calculator. So my coefficients are, whoa, I was going to say, I just made this problem up in 1, 1, 2. I was going to say if it, the first row is actually the same. 2, -5, and 8. Alright, so now I'm going to quit and then go back into the matrix, and we'll choose the blue pill, which is to do math, and that is reduced row echelon form. Right there. Rough. Reduced row echelon form. And we are going to do that to matrix A. So I'm going back into the matrix, and I'm choosing A. Ah, 2.5714, etc. All right, so I don't like decimals, especially when we're going to have to integrate it. So I'm going to go math, enter, enter, and it changes the whole matrix into fractions. Did you know it could do that? Kind of cool, huh? No, it's like, yeah, I knew that. All right, so a calculator said that it's 1/018/7/01. This is -4. So this is reduced row echelon form. If you get a matrix in reduced row echelon form, here are your solutions. So that's your A, and that's your B. So A is 18/7 and B. Do you remember doing this, reduced row echelon on a calculator? You did that. Like you had a whole chapter with Mr. Frisbee where...
That was the last one we did.
Oh, it was?
We did it online.
Okay. But all you had to do is set up the equations and then your calculator would solve them. Yeah, that's a good way of learning. Okay, so we figured out A and we figured out B. So I'm going to write it down here, 18/7 without you seeing it right now, and then I'll show you. Okay, so there's my A, there's my B. So if you get a fraction, you can just put 18/7. That's a better way of doing it. So now remember, we're trying to integrate. So up here, it's hard. I'm not going to. Up here, this integral becomes 18/7 minus 4/7x plus 2. Okay, so this, we can find the antiderivative. The 18/7, you can think of that as just floating out front. Antiderivative 1/x minus 5 is the natural log of absolute value of x minus 5. Minus 4/7 natural log absolute value of x plus 2 plus c. Okay, so it's a way of evaluating an integral, find the antiderivative. This is called partial fraction, rewriting a fraction in different terms. Okay, so that's just one example. Let's try one. Let's do number. We could try number 1 from your worksheet. That way you don't have to do it twice, or you don't have to do the second one. Okay, so integral of 1/x squared minus 1. Okay, so if we were trying to figure out the antiderivative of this, we don't know it. Okay, the bottom is factorable, so that's a good sign that we might have to do partial fractions. So we're going to rewrite 1/x squared minus 1 using partial fractions. So I'll give you a couple of minutes to try this problem. you all have the work in front of you, so you know if you're doing it correctly. So I'm just going to work through it up here, even though you already have it. So notice there are no x's on the left side. You still need an x equation, number equation. So I have 0 x's, that equals a plus b. And the numbers, I have 1 equals negative a plus b. Definitely easier to do it by hand, especially since their a's are opposite. So I get 1 equals 2b, so b is 1/2. So looks like a would be negative 1/2. So this is kind of what I have for my integral here now. The negative 1/2 just floats, so natural log absolute value of x plus 1, 1/2 natural value of x minus 1 plus c. What questions do you have on that problem?
On the first one?
Yeah, this one right here. That's good?
Why the absolute value?
Why do you have to do the natural value? Absolute value here?
Yeah.
So the antiderivative of 1 over x is natural log absolute value of x. And it's the case because if you look at 1 over x, looks like this. If I just did, and we did integral of 1 over x dx, this is defined for everything except for 0. So if we just said the antiderivative would be natural log of x, that's only doing the right side of it. So we go absolute value, and then that addresses the left side of it also. Okay, so kind of like integration by parts and u substitution, you learn one way, but there's always going to be more complicated ways, or complicated types of problems. So how about if I have how about, geez. Okay, so that's an x cubed. So if you end up with this, and I'm just going to rewrite it in factored form because I kind of butchered that one. So I'm going to factor out an x squared, and I'm left with x minus 2. Okay, so I've got two factors on the bottom, like x squared and x minus 2. But you can also think, one rule for partial fractions, if you have something multiplicity 2 or more, so if I have something squared, multiplicity 2, or something cubed, you have to assign a value to each of them. So I'm going to do an a over x squared, and by each of them you have to go all the way down. So if that's x squared, you also need one for x. If it was x cubed, you could do a over x cubed, b over x squared, c over x. So if there's something squared, you're going to have to do two of them. If there's cubed, you're going to have x cubed, x squared, and x. And I still have my x minus 2. And it doesn't matter what order. This could be b, that could be a, this could be a, because you'll get the same answer. Okay, so that's another rule. If there's something of multiplicity 2 or greater, you have to work your way down. So now it would be kind of the same thing. We'd multiply both sides by x squared times x minus 2. Right here it would be, that would cross out, so we'd have 2x squared plus x minus 3 equals a, these x squareds cross off, so it'd be a times x minus 2, and b, only one of these x's cross off, bx x minus 2, plus c, just the x minus 2's cross off, so cx squared. So 2x squared plus x minus 3 equals ax minus 2a plus bx squared minus 2bx plus cx squared. So this would be an example where we have to have 3 equations. You need an x squared one, you need an x one, and you need a number one. So how many x squareds do I have on the left? I have 2. And on the right I have b plus c. On the left, the x's, I have 1x, and I have ax minus 2b, and the number, I have negative 3, and I have negative 2a. Alright, so if you wanted to do it by hand, algebraically, you could divide by 2, you get 3 halves. Dump that in here, then you can find b. Dump that in here, you can find c. So I think that's probably the easiest way. But again, if you're going to use a matrix and it wasn't that easy, I would write it, well, I could write this as negative 2a equals negative 3. And the a's are supposed to align, so I have negative 2 a's in the first column, 0 b's and 0 c's for my first row, and then it's negative 3. Then I've got a 1, a negative 2, I have 0 c's, and that's equal to 1. I have 0 a's, I have a b, I have a c, and that equals 2. That would be the matrix that you'd put into your calculator, reduce row echelon form, and you get your answers. And once you get A, B, and C, then you would plug them back into this form to figure out, the next step. I might as well finish this problem, because you never know what it's going to bring. It might be a U substitution after integration by parts, or not partial fractions. All right, so I'm going to edit. This time it is a 3 by 4. Enter. Alright, so A is 3 halves, B is 1/4, and C is 7/4. Alright, which means we have 3 halves, and then could go that you'd have something more involved with our finding the antiderivative at that point, but this one looks pretty straightforward. So I'm going to call that good. Okay. So why don't you at least set up the partial fractions. So get to this point right here with this next one, just so I make sure that you understand how to at least set them up. Oh yeah.
I left at the very end of column 2. And I was looking at it. And I don't get how you go, or you get that negative 112 already.
Alright, so I have x squared plus 4. I can factor out an x. X plus 1, x minus 1, and then all right, so far so good. Okay, so let's say I have 2x squared minus 3x plus 1 over Alright, so here's another type. So we're going to factor the bottom, so you can pull out an x. So I have 2x squared minus 3x plus 1 over x times x squared plus 4. Now x squared plus 4 is no longer factorable using the... You can't factor this anymore. So we have a non-factorable quadratic factor on the bottom. Non-factorable quadratic. Okay, so it's got an x squared and you can't factor it anymore. So what we need to do is, I'll put an a over the x like you normally would. But now since this is not factorable, I'm going to throw a bx plus c above it. Okay, so if we have a non-factorable quadratic, we need a linear on top. Bx plus c. If that was the first one I chose, it would be ax plus b over that, and then just c over x, but it doesn't matter. Okay, so that's another condition you have to remember. And then we would just proceed with the same process as we did before. All right. Another type. It's the last type I can think of, at least right now. If I have an integral of 2x cubed plus 4x squared plus 6x minus 1 over Alright, let's say this is our problem right here. Okay, if we proceed, right now we've got just a quadratic on the bottom and I have a cubic on top, and that's something different that we've had, and that's not possible to do partial fractions yet because it's considered improper. The degree on top is the same or greater than what is on the bottom. Okay, so if this is higher or equal to the bottom, the degrees, you have to do, I'm going to guess there's going to be a groan here shortly. Polynomial division. No groan, a couple smirks, a head shake, and a grunt. I like it. Okay, so you have to divide this into this. We can't even use synthetic division here because we have a quadratic. It's not just x minus 4 on the bottom. If that was the case, we could use synthetic, but it's x squared minus 4. So we have to figure out x squared goes into 2x cubed, 2x times. 2x times x squared is 2x cubed. 2x times negative 8, I'm going to put it right over here, minus 8x to align the x terms. One thing to remember, if we don't have an x term or an x squared term, you have to put a 0x. Okay, so now we have that. We're going to subtract. That's gone. So now I have 4x squared. 6x minus a negative 8x is 14x. Bring down the minus 1. X squared goes into 4x squared 4 times. 4x squared minus 16. Subtract. Gone. 14x negative 1 plus 16 is plus 15. Okay, so this is the same as integral of 2x plus 4, because that's what we got when we divided. But then we've got a remainder of 14x plus 15 over x squared minus 4. So we divided it using partial fraction, polynomial division, sorry. Okay. Antiderivative of x squared is, or 2x is x squared. Antiderivative of 4 is 4x. Plus, antiderivative of that, I don't know. Let's do partial fractions. A chuckle, a head shake. You're now looking at posters on the wall. We're all coming down off our sugar high, I think. All right, so this, we just spent 20 minutes figuring out how to do that. Okay, so you do partial fractions with the remaining stuff. Don't forget about what we already have here in our solution. Our answer is going to be x squared plus 4x plus whatever we get when we do all that stuff. Okay? Questions on that? Are we a fan of polynomial division? It's not, is it? It is that bad?
I relearned it again this year to help someone learn it, so.
I like it. I especially like synthetic division, but polynomial division is kind of fun too. Okay, so just if we have something as easy as x plus 4 over x minus 1 dx, that's still considered improper because they're the same. So we could do x minus 1 goes into x plus 4, because I don't know what the antiderivative of this is. There it is. Magic. Okay, I don't know what the antiderivative of that is, so I'm just going to divide the bottom into the top. X goes into x one time. Nothing. 4 plus 1 is 5. So it'd be 1 plus 5 over x minus 1. So integral of 1 plus 5 over x minus 1 is x plus 5 natural log absolute value of x minus 1 plus c. So if they're the same, you still divide it. Don't forget to do that. Some people are going to look at a problem like that on a test or quiz and like try u substitution, try all these different things. Just if you know where to start, it's not a terrible problem. All right, questions on partial fraction stuff?